Next up, we got to keep moving forward. We have lots of cool things to show. Next, we have Nico Pays talking about enhancing test readability with extension methods and Fluent interfaces. Hello, Nico.
Hi, Kendra. How are you doing?
I'm good. How are you?
Fine, thanks.
Excellent. If you want to take it away, I'm excited to finally get a testing talk. That's my jam. Let's do it.
Okay, here I go. Hello, everyone. I'm Nico Paez. I'm a software engineer. I share my time between industry and academia. I am a professor. I teach software engineering, and I'm a TDD fan, right? So that is why I'm talking about tests, right? So let's start. So the motivation, why test code matters. There are several reasons for that. Let's review some of them. First of all, if you work in a CD, CDI context today, which is something very, very common, um, tests are first-class citizen because the test represent your safety network. You plan to be updating your application very frequently, and you don't have time to run manual tests, so you need automated tests to give you some security on each update, on each deployment, right? At the same time, if you work in an agile or extreme programming way, well, tests are documentation, right? You, beyond using TDD or not, you will have tests in this context. And of course, working in an agile way is something very common nowadays. And in that context, tests are documentation. And of course, when you read your documentation, you want it to be clear, right? And something that is very common, you create some code, you write some tests, and when you have to update your code, of course, you will have to update your tests. So this again make test a first-class citizen, right? Of course, that if you are practicing TDD, your tests are a design tool. So again, this gives test more and more relevance, right? And something that is interesting when you start thinking about test is that your test code is specific, while your application code is generic. You have to prepare your application to handle several situations that you can not, how can I say, sorry, your application code is generic. You have to manage several situations, but your test code is specific. You in each test you are addressing one specific test case, right? That implies that when you are testing your application, it's possible to have much more test code than application code, right? That's not infrequent when you practice test-driven development, right? And something interesting is that when you start paying attention to your test code and you find yourself reading test code that is not clear, sometimes that situation signals some design smells in your application code. If you have to write a test and your test is really long and you have to perform several setups before running your test, that may be a design smell in your application, right? So finally, we find that usually test cases share structure, right? Because you have to test a certain feature, and for that certain feature, you need to test several cases. Many, many times, the difference between the different cases you want to test is just a small difference in the step, a small difference in the test data that you will use, a small difference in the assertions that you will run. So that make test code very easy to be duplicated, right? Something that, of course, that we want to avoid, right? So in order to tackle these situations, in order to follow this motivation, I want to share some techniques that will help us to have more readable tests, right? So the first of them is the object mother pattern, right? Here you have a link. So basically, a very easy definition for this pattern is a class that provides methods that create valid and customizable domain objects. In other words, an object matter is just a factory object, right? But with some specific conditions. It won't create application objects. Sorry, it will create application objects, but to be used in your tests. I mean, your application won't use the object matter. Your test code will use the object matter to get application objects, right? Your application object, your domain objects may be quite complex to build. And of course, at the same time, you may need different combinations of your objects with different data, with different status. And the object matter will simplify that setup, right? Another technique is the builder pattern. You may already be familiar with this. We will use the builder pattern when creating our objects requires let's say, a more complicated setup. And finally, we will use Fluent interfaces. This idea of Fluent interfaces, here you have a easy-to-read link by Martin Fowler. A Fluent interface is just a way to organize our code in order to make it fluent when you read it, and of course, when you write it, right? I will show how to use this, right? These three techniques are able to be applied no matter what language you use, right? But when we come to C#, we have some additional techniques to apply. In fact, we have specific tools in the case of C#, right? So the first tool I want to mention is the Fluent assertions. This is a very simple library that, following the Fluent interface idea, provides Fluent assertions. The best way to explain this is just an example, right? So here we can see different assertion styles. The first situation is the traditional n-unit assertion, right? Assert at equal, and you give it to different things you want to compare. That has been present in the test framework for a long time. You can find similar methods in every XUnit tool, right? JUnit, NUnit, XUnit, wherever you want, you will have something like this, assert at equal. In the recent years, NUnit included a new type of assertion that is more specific. This slide is not updated. I will show this in code, it doesn't matter. In the recent years, NUnit added another assertion that is called assert that, and that allows a bit better, more readable way of assertions. And the last one that I want to focus here is the Fluent assertion. This is part of the Fluent assertion library, and look how it looks. Function transfer state should be, these are like extension methods provided by the Fluent assertion framework, and this allows you to read in an easy way, we could say, right? With more, well, in a fluent way, right? The other thing that is interesting to add, the other tool that we have when working with C# are extension methods, right? Extension methods, for those of you that are not aware of this, are methods that are defined outside of a class but can be applied to objects of a certain class, right? So the way that we use this in the context of tests is that you will have your domain objects, and we will write extension methods in order to simplify the manipulation of our domain objects. That's it. So I think that this is enough, and let's go to code. Here I have my code. You can access at GitHub. I already shared my solution there, so you can check it there. And let's browse the situation. Okay, for this demo, I have a very simple domain, a bank domain, where we have a funds transfer object that will perform funds transfer between bank accounts. The bank account belongs to a customer, and the bank account is located in a certain branch, and the branch is related to an address, of course, right? So this is my simple domain model, and let's see how it works. So in code, this is my sample project, just the domain project, a class library, and then another class library for the test. In this case, I'm using traditional end unit, right? So we can see we have our bank account and our customer and our funds transfer, right? That it's been created, some validations are run when it is created, and then we have an execute method that just take the money from one account and put it into another, and of course change the state of the funds transferred, right? So let's see how we test this. I developed this small domain using TDD. So we have here the corresponding tests. As you can see, I have tests for the main classes. For the branch and the address, I didn't add tests because they have just a bunch of data with no behavior at all, right? So I have tests for the fund transfer, for the customer, for the bank account. But beyond those tests, I have prepared 2 additional classes with tests after and before applying the techniques I have mentioned here. So let's start by analyzing the tests without applying the techniques I mentioned here. So here we have this test before refactor. And in this case, we have a first test method that tests the funds transfer state is pending when created. So this is what we want to test, right? As you can see, this is a classical test with 3 stages. In the first place, we have the arrange, when we prepare the context for our test. Then we have the act, where we perform the action that we are trying to test. And finally, we have the assert, where we verify that things are expected. Look at this. This is the key part of our test, but in order to be able to execute this, we have to perform some setup actions. And this is just testing my domain. We are not testing infrastructure that sometimes that requires some more preparation. The point here is that I want to test the funds transfer, and for that, I need 2 accounts, the source account and the target account. But in this case, the bank account has 2 collaborators. We have an owner, the owner of the account, and the branch where the bank account belongs to. So in order to create my bank account, I need these 2 objects. Of course, that in some situations, I could just put null here, but that could bring some, let's say, collateral effects, right? Some unexpected situations. So I will pass it some objects. Of course, that another option could be just mock these objects. Yeah, of course, that's an option if you are a mockist, right? You know, inside the TDD community, there are different TDD styles. One that is based on mocks, and another one that reject mocks, right? So in this case, I decided not to use mocks, so I have to create my objects, right? So to create my account, I have to create a branch, and for the branch, I need an address, and I need also a customer that is the owner of the account, and for the customer, I need a fiscal identifier, right? That the fiscal identifier is just a GID, right? I just have this test data generator that generates a GID. That's all, right? So this is my test, right? This is like a unit test. I'm just focusing on the creation of the funds transfer, right? I can run this. And beyond this, I have a second test. Yeah, okay, it worked okay, excellent. And I have a second test that is a little bit interesting. Funds transfer, debit in source account and credit in target account, right? So in this case, the setup is similar, but it's different what we are executing. Our act is this one. We are testing the execution of the funds transfer, right? So here I create the funds transfer, and here I perform the extract of the money and I move the money here, right? But again, in order to be able to execute the funds transfer, I need to create the funds transfer, and to create a funds transfer, I need several things, right? The same things that I needed before, but in this case, I need some additional setup. I need to put money into the source account, right? And also I need to know how much money I have the target account. And as you can see, I have here like 3 asserts, right? This is not a unit test. We could say that this is like an integration test or a component test or a social test, because I'm not testing this isolated transaction. I mean, I'm not testing the funds transfer in an isolated way. I testing the funds transfer object when he interacts with the sources, with the source account and the target account, right? That's why I call this a social test. So this is my code, and I think that applying the techniques I previously mentioned, I can make it much more readable. So let's see how this looks after the refactor. This is the situation we have. This is the first test. As you can see, these first lines, I don't matter any of this for this test. I'm just testing the state of the funds transfer when I create it. I don't want to know all this stuff, right? So what I did here, I have my object matter, and I just say, just give me a bank account, right? As you can see, this is like a factory method, right? Just give me a bank account with some preset configuration, and this method will take care of all the complex things, right? It will create the address, the branch, the customer with some default values, and just instantiate the bank account and give it to me, right? So this code is much more simpler than the previous version, right? And in the case on the other test, in this case, I need a source account, but with a certain state. So I ask my object mother to create a bank account, and I need that bank account with certain balance, right? So in this case, of course, one option could be just put here the parameter, right? How much money I want in that account. But I decided to implement this with an extension method to set the balance, right? So we have the create bank account, and then we have the extension method, right? That, of course, operates on a certain bank account, right? And I set here the amount of money I want on that bank account, right? And I also abstract the detail that in order to put money on that bank account, I have to call the credit method, right? So even more, this extension method could be used on any bank account, right? inside my tests, right? The extension method is only available in my test code, right? So this allowed me to have this simple code, right? And in this case, I'm using here the second end unit assertion style that I mentioned previously, right? Assert that source account balance is equal to. I could refactor this into the Fluent assertion style and just say source account balance should be 400, right? This is exactly the same as this, right? But this is in a Fluent assertion way, right? So I will replace it. Thanks. And going a little bit further with this, let's suppose we have another test here where the branch is relevant, right? In these two tests, the branch was not relevant, right? But for certain situations, I may need some specific state of the branch, right? So how could I manage that? Well, first of all, we could say, well, let's use the object matter and let's add to the object matter after the bank account, we create some additional extension method to set the branch number, right? We could do something like this, right? Or at least we could try, right? So we can create this at branch number and make this method, the extension method, to create a branch and set the branch of the account. But we will have a problem in that situation, right? Look at this. I have my object matter here. Here is my balance method. So I will create another extension method that we will call at branch. Of course, when you create a Fluent interface, that is what I'm trying to do. I have to return the object where I'm trying to operate, right? So my extension method receives a bank account and, sorry, my Fluent method receives a bank account and returns a bank account, right? So I have to return a bank account and I receive this extension method. So this is my syntax, bank account. And this should receive, for example, the branch number, right? So here I could try to do something like this, right? But the problem here is that if the bank account is already created, I cannot change the branch, right? As you can see, this does not allow to change the branch, right? This is just a read-only property. Well, not a read-only, but a private set, right? Just to be used when you create the bank account, right? This is like a domain-driven design restriction. From a conceptual point of view, in this domain, when you create the bank account belongs to a certain branch, and you cannot modify that branch, right? So in this case, I cannot apply this technique, right? The object matter will be very useful when you have to operate on properties or methods that you can operate, right? In this case, I cannot use the object matter to operate on the branch because the branch is not settable, let's say, right? So what can I do in this case? I can use another pattern that is the classic builder pattern, right? So let's forget about this and let's look at this. In this case, I have an object builder I say the object builder, I want a bank account for the customer John at the branch 1 with balance 500, build, right? And here I have that account with that state, right? How does it work? Well, the object builder just takes these parameters, and when I say build, at that point, the object builder calls the constructor of the bank account in this case. Look at this. I say bank account, it just creates the object builder and returns it. Then I say for customer John, so the object builder just take that name and store it and returns the object builder, so I can continue my chain of methods. So I say at branch 1, and it stores the number of the branch. Finally, I say the balance, and it stores the balance. And at the end, when I have set all the properties I want to use, I just call build. And at that point is where the object builder will take all the information that is stored, and finally it will create the bank account, right? Look at this. I may use these methods without some of them, right? So in order for this to work, I have some logic here to set some properties with default values, right? If the customer name is set, then the builder will use that name. If not, it would call it Mary, right? If the address, well, I have the address is not relevant for this, so I have a default address object, but the same happens with the branch number. If the branch number is set, okay, use it. If not, use branch number 1, right? And something similar with the balance, but it's a bit more complicated. If the balance is not set, okay, just return the account as it is created. But if some balance is set, then put that money on the account, just perform a credit operation. Well, I think this is all. That's it. I don't know if you have some questions.
Yes, we do. So thank you so much. That was very interesting, very great, clean test code with writing extension methods without having to change your actual production code, and all of your tests actually look readable and legible. It's so good. So one question was, what is your personal approach to doing spec flow or business logic testing versus unit testing, method or functional? So how do you kind of split between the two? And is the simplest form of spec flow just becoming a unit test anyway?
Okay. I do both of them. I follow what is called the London approach, or the London TDD style. You can check about this in a book that's called Growing Object-Oriented Software Guided by Tests, right? Growing, here it is. Show me an image, please. So this book is great, and as you can see, this is the key to your question, right? You will write a failing acceptance test using a spec flow. That is a test from the user perspective, right? That will check a business transaction. But in order to make that test pass, you will have to do some small tests on your objects, right? So at this point, you use a spec flow, and at this point, you use a unit or another more developer-centered testing tool.
Great. Well, thank you so much. We had a few more questions on Twitter if you want to hang out there and keep a look on your notifications. But thank you so much for joining.
Thank you so much. I will check the questions on Twitter.
All right.